Hello and welcome to my channel. I'm Mustafa Persokhan. I'm an optomechanical engineer and I have PhD in optics. Today we want to talk about epoxies for optical applications. Mostly, I'm going to talk about optical applications. So first, we need to talk about why we need to use epoxies, why epoxies are good or better than the other material. First, epoxies have, most of the time, they have very high physical strength. So, for bonding metal to glass, they can actually tolerate the weight of the glass or big mirrors. So have a good physical strength. They most of the time they have good chemical resistance. For example, when you want to use them in harsh material, even harsh situation, even when you want to use them at very high humidity, humidity can cause degradation of most of the bonds, but epoxies are pretty good in that case. And they can have a good adhesion to variety of substrate. For example, you can use them between metal and metal, metal and glass, glass to glass. So we have a wide variety of applications for epoxies, and they can actually tolerate very high temperature change or temperature difference. You can use epoxies for cryogenic applications for up to 300 Celsius applications. So epoxies are pretty good for different kind of situation. So we have, mostly we have two different kinds of epoxies, two component systems and one component system. And each of them, they have their own trade-offs. For example, when you're using two component system, a good thing about two component system, they can cure at ambient temperature. You don't need to cure them at higher temperature, which is pretty good for optical system. And good things about, one component system is that you don't need to mix them because they just come in one part and you inject them and you let them cure. But for two component system, most of the time it comes with two parts. That we have part A and part B, and you sometimes you need to actually measure weight or volume very accurately. But these days there is some kind of different kind of packaging. For example, Master Bond has a kind of epoxies that have two uh, parts in one bag. They call it flexi bag, I think. And there is a separator. We can remove separator and mix them together with a pretty accurate amount of epoxies that the company put there. So you don't need to do that kind of measurement, which is a kind of uh, they find a solution for solving this problem. I mean, mixing at very specific ratio. And so, based on all I said, curing at room temperature, those are pretty good for optical materials. Because most of the time, for optical materials, we don't want to increase the temperature. It can cause stress on glass, or most of the time we don't have a good mismatch. We don't have a good CT match between metal and glass, so we don't want to change temperature that much. So two component systems are pretty good for optical systems. Okay, and the temperature that you need for one component system is around 250 to 300 Fahrenheit, which is equivalent to 120 to 150 Celsius. And one thing that we should be careful about that is that the curing process is a continuous process. You cannot have that kind of system that you start curing the process at high temperature and then you lower the temperature at ambient temperature. Your curing process is not going to continue. It's going to stop at here. So it should be a completely constant temperature for a long time or for a time that vendor is specified for the curing time. So it's a continuous process. This is something that we need to be aware of that. So for two parts epoxies, we have a few terms that we need to be careful about using them. One term is open time. Open time is the time that we have after mixing part A and part B. Because open time, when you mix epoxy together, you have a specific amount of time, which is around 5 minutes to sometimes 1 hour. But your epoxy is the curing process is gonna start at the time that you mix them together. And we have different phases. First is completely liquid, then it gets changed to gel, and then it completely gets solid. And as you can see in this graph, it depends on the temperature. At lower temperature, you can have epoxy at the first phase, which is the liquid phase, for longer time. But when you go to lower temperature, this transition is going to be shorter. So we have handling time. Handling time is the time that we have epoxy for setting on the part. Sometimes for optical parts, we want to inject or apply epoxy and then do some kind of tweaking and alignment and let it to cure, and then again retweak it because of creeping, that kind of stuff, and again let it to cure. So we should be very careful about the handling time, because if you pass the handling time and when it started, really cured, you cannot actually align your system, align your optical system. So the handling time is pretty important. And we have cure time. After we finish the handling time and the rest of the epoxy, you let it to cure, that we call it curing time, which as I mentioned, for two parts epoxy, curing time is going to be very long, sometimes 5, 6, maybe 10 days. But when you have one part epoxy that you can use uh, 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 heat or UV light, or for two parts of also you can use it UV, but it's gonna be shorter because it depends on the temperature. Even for two parts of epoxy, you can uh, decrease the time by increasing the temperature, but when you want to do it at ambient temperature, most of the time it's going to be a long process. And as I mentioned, for two parts of epoxy, it will take many days, and it depends on the temperature. So another term that we need to be careful about that is exotherm. Exothermic process is the process that they're going to generate heat, that we call it exothermic process. So for epoxies, we have two different exotherm. One of them that we call it low exotherm, and the other kind of epoxy that we call it high exotherm. So for low exotherm epoxies, you can use them for uh, longer open time because they are lower exotherm, is which makes sense. You have lower heat generation, and heat can cause uh, curing, so you have longer open time. And the epoxy cure more slowly, and because your epoxy is curing more slowly, it can be used for thick encapsulation, which most of the time when we say thick, it means that we can use it for to 1 inch. Higher than one. Higher than 1/4 of inch. So something that higher than that, we can call it for thick application. And we have higher exotherm. So when you have higher exotherm, it means that when you mix them, it's going to generate a lot of heat. So it has a limited work lifetime, and they get cured quickly, and it cannot use for thick application. So most of the time when we say it cannot be used for thick application, it means that we are talking about 1/4, less than 1/4 of inch. So that's the kind of thing that we need to be worried about, that exothermic and lower exothermic and higher exothermic. And we're going to continue that kind of discussions about epoxies. Thank you very much.